All right, week 3 of distance learning. Today we're going to take a look at areas of circles and sectors. So the first thing we'll see vocab-wise, sector of a circle, and then segment of a circle. So first thing, area of a circle. The area of a circle is equal to pi times the square of the radius. So whatever the radius is, multiply that by itself or square it, and multiply it by pi. So here, an outdoor accessories company manufactures circular covers for outdoor umbrellas. If the cover is 8 inches longer than the umbrella on each side, find the area of the cover in square inches. So we know that the diameter of the umbrella is 72. So the diameter of the umbrella is 72. So the radius of the umbrella is 72 divided by 2, or 36 inches. So now that we know that, we also have the 8 inches that's being added on. So we need to add on, for the radius of the cover, that's going to be the 36 plus the 8 inches on the right side. So that's going to get us a radius of the cover of 44 inches. Now that we have the radius, we can go ahead and find the area. So the area of the circle is equal to pi times the radius squared, or pi times 44 squared. 44 squared is a pretty big number. It doesn't say to actually round it anywhere. It does say in square inches. That's about it. That's the unit. So we'll get the exact number first. So 44 squared is 1936. So 1936 pi square inches is our exact answer. Now, if we want to round it to the nearest hundredth, let's say, then it comes out to be about 6,082. Not 6,000, that can't be right. Sorry, a little brain fart. We're multiplying by pi. So yeah, it is 6,082.12 square inches. My bad. But there we go. So we have our exact answer, 1,936 pi inches squared, or a rounded number of 6,082.12 square inches. So now we want to find the radius of a circle with an area given to us. So we're working backwards with our formula here, still using the same formula. Area of a circle is pi r squared. Now we don't know our radius, but the area of the circle is 58 square inches. So we just plug that in. 58 equal to pi times r squared. We divide both sides by pi. And now we're going to either get our decimal now, or we need to round our answer. So we're going to leave it. And so we have 58 pi equal to r squared. To get r by itself fully, we need to square root both sides. Typically, we would want to do plus or minus, but again, we're dealing with real-world situations here, so we don't want to deal with the minus part of this because it's the radius of a physical thing. So, square root of 58 over pi, and we're going to go ahead and jump straight to a rounded answer for this one, and that gets us about 4.297 square inches. Again, it doesn't say where to round, so we'll just go to the nearest thousandth, especially since it's, not inches squared, just inches, it's the radius. But nearest thousandth just because we have a single digit in our ones, no tens or anything. So now, looking at the area of a sector. So the sector of a circle is just like a wedge of a circle, and which we've looked at before in this class. We had to deal with it when we did our crop circles project. But the area of a sector, to find that, you have to multiply the area of the whole circle by the proportion of the circle you're looking at. So you're going to look at the angle that you're forming, the central angle, and you'll divide that by 360 since the full circle is 360. And then you multiply that fraction by the area of the entire circle. So it's like you're getting the percentage of the circle you're looking at. So our problem here, a pie has a diameter of 9 inches and is cut into 10 congruent slices. What is the area of one slice to the nearest hundredth? This one actually tells us where to round finally. So here we have some options. We have our formula, first of all. The area of a sector is equal to the central angle measure over 360 times pi times the radius squared. So now, that's our normal equation, and we don't have our radius, we have the diameter for 1. So the radius is just the diameter over 2, or 9 over 2, or 4.5. So now that we have our radius in inches, we're ready to look at the rest of it, right? So we don't know what x is, because we don't know what the angle is of the slices, but we do know that it's 360 degrees, a full circle, divided by the 10 congruent slices. So really, our x is 360 over 10, or 36. So we can use that and plug it in and just divide, but we know that we're dividing a full circle into 10 congruent pieces, so our x over 360 is really just 1/10, because it's 1/10 of the whole pi. So now we just plug that in. Instead of having the x over 360, the area of our sector is 1/10 of pi times, it's weird that we're using pi talking about pi, right? We missed Pi Day, unfortunately. It was the weekend after to start spring break. Hopefully it's on a school day next year. It was last year, which was the first time in a long time it's been like that, for us at least. So our radius of 4.5 squared in there. So now we're going to break this down. So 4.5 squared is 20.25. And then 20.25 divided by 10 would just move our decimal place to the left 1. So this is now 2.025 pi. Now this does tell us where to round, so we don't have to have this exact answer. This is the exact answer, but we don't need it. It does tell us where to round. So this is going to be about 6.36 square inches. That is it for these notes. See you next time.